Well, hello one and all, and welcome to our short on API calls. Now, an API is an application programming interface, a way to talk to some other application, perhaps over the internet or in your own code. So today we'll focus on accessing an API over the internet, and we'll focus on one particular API, the API for the Art Institute of Chicago. Now, the Art Institute of Chicago is a museum based in Chicago, and they have an API, a way to access all of the artwork in their collection and display it in our programs as long as we make the right request. So let's see how we could do that. Well, if I want to write a program here to access the API for the Art Institute of Chicago, I could start by writing a program here called api.py. I could then import a Python module called requests that allows me to send requests over the internet to the Art Institute of Chicago. I'll make for myself here a main function, and I'll leave it maybe empty for now. I'll go down below and call main as well, and now it's up to me to use the requests library to access the Art Institute of Chicago's API inside of this main function. So how can I do that? Well, I can actually look at the documentation for this API from the Art Institute. I can show you what it looks like a bit here. Here is their documentation as to how to use their API. And I focused on this particular, what we might say, endpoint, a way of accessing the API. This one is called /artworks/search. It's a way to search artwork in the Art Institute's database or in their collections. So let's try just sending a request to this particular domain, /artworks/search, this particular route, let's say. I'll go back to my program, and if I wanted to send a request there, I could use requests.get. And notice how .get here is the same way that the Art Institute said I should use this route. I should use a GET request, HTTP GET request, to access whatever data they have at this particular route. So I'll use GET in my code, and I'll then type in the URL that they have asked me to use elsewhere in the documentation. They asked me to use this URL here, https://api.artic.edu/api/v1. This is the route to their API, the place they make their information available to access. But I want to use one particular route of their API, in this case the /artworks/search route to search artwork in their collection. So I'll go ahead and append here /artworks/search. And let's see what we get. I'll store the results of this in a variable called response, and why don't we just print response to see if everything went okay. I'll come down below to my terminal, I'll type Python of api.py, and I'll see response 200, meaning everything in this case was okay. 200, of course, referring to that HTTP status code that means everything went okay with our request. So it seems like the Art Institute has acknowledged our request to search some of their artwork. And this is what an API is. It's me sending a request to, in this case, the Art Institute, and them responding back to me with some info I might have requested, allowing me to access their data and include it in my own program without worrying how I can directly search their collections myself or have it stored on my own computer, let's say. So how do I get access to the data inside of this response? Well, it turns out that according to the Art Institute, they're going to send us back this data in the form of JSON. JSON stands for JavaScript Object Notation. It's a very common format for sending data over the internet. So if I want to read that JSON, thankfully, this response object comes with a way to do that. I can simply type response.json, and this will convert that response into a JSON object I can actually read. In this case, I'll call it content. And now let's try printing content. I want to, of course, get the response, convert it to JSON, and then print the resulting JSON that I've gotten. And we'll see what that looks like here. I'll run Python of api.py, and now I see some JSON down below. If you're not familiar with JSON, that's okay. JSON is simply a collection of keys and values. In this case, let's see if we can find a particular key. I might scroll up a little bit here And why don't we see, oh, one like this, license links. This is a key. We know because it begins, it precedes a colon here. The value is, in this case, all of the links to the licenses for, I guess, this one particular artwork. Now, let's go ahead and try to make this a little more readable for us as humans. Often you're not simply reading JSON as just as this. It gets a little tricky to read. So I know by reading the documentation that actually the key with the values I'm looking for, in this case for artwork, is actually one called data. So if I clear my terminal, go back to my program, and update this program, I could actually do this. I could say for artwork in content data, just like this. And this is saying that in the content JSON object I received, there is a key called data. I know this because I read the documentation from the Art Institute. This key leads to a value that is in fact a list of artwork. So I'll say for artwork in this list of artwork that I know I got back per the documentation, why don't we go ahead and print what that artwork could look like. I'll go ahead and print, in this case, I'll make it pretty. I'll make an F string with a little bit of a bullet here, and I'll say something like artwork. And I'll also go ahead and use another key here that I know exists from reading documentation, one called title, just like this. So if I go ahead and run Python of api.py, hit enter, I'll actually see a list of some of the artworks that I got back by querying this particular route of the Art Institute's API. So here I am using the API to access some data over the internet and use it in my program. I simply had to read the documentation to understand the structure of the response I would get back and what keys I should use and what values they would give me. But let's think of what could go wrong if I'm trying to access, in this case, something over the internet. Maybe my internet connection is slow, I lose internet connection, lots of things can happen. So if you are going to query APIs you find online, it's best to have some checks to make sure that your request is actually working as you expect. So let's try this. Why don't I go ahead and use what I've learned about exception handling in Python. I know that there is this keyword called try, where I can try to do something, and if it doesn't work, we'll do something else instead to handle that particular case. So it's best practice to try this request because we aren't sure if it'll work. Maybe our connection is slow, maybe it breaks up. We might not be sure this is actually going to go through. So I'll try to get this response back, but if that doesn't work, it turns out in the requests library, it'll raise this exception, requests.http error, meaning there was an error with our HTTP request, a request we sent over the internet. If that's the case, why don't we just tell the user, I'll say maybe something like print couldn't complete request, just like this, and I'll go ahead and exit the program initially just by hitting return here. And this will say our program is done. We won't continue down below as well. What I want to make sure I do, though, is also this, and this is just per the documentation in the requests library. I want to make sure that I call response.raise4status. What this does is as follows. It says, I'm going to try to make this request to the Art Institute's API. I'm going to then check if the response actually worked as intended. If it didn't work, didn't give me back that HTTP 200, everything is okay, I will raise this requests.http error, and I will then handle it like this. I'll say couldn't complete request. So best practice here to make sure that if things don't work out, we're handling them a little more gracefully. But what else could we do with this API? We've seen how to make this request a little more robust, but it's not that exciting. If I run it again, we really just see the list of maybe the first 10 or so artworks that the Art Institute wanted to show us. APIs can be a whole lot more powerful than this. In fact, they get more powerful when you introduce parameters. So let's go back to the documentation here, and I can show you how I would read this. I notice that I can query the /artworks/search route, and this is supposedly a way to search artworks within their collection. But they also give me some available parameters, some ways to define my search. So in this case, there's a parameter called Q, and I can actually make that parameter a search query. Maybe I could type in somebody like Monet and get back paintings by Monet. Let's try it. So if I want to query this API, send a request to it, but also get back a particular search result with this parameter, I can do so as follows. I can go back to my code, and I can actually make use of another argument to the .get method in the requests library. I'll go ahead and style this just like this. We're still going to send a request to this particular route of the API, but now, as the next argument, I can actually provide a dictionary of keys and values. In this case, the keys will be the parameters to this particular URL. So in this case, the parameter, again, was called Q. I know this because I said the parameter was called Q over here. I can then type in some kind of some query. I might type, in this case, Monet, just like this. And now my request is a little more parameterized. I'm searching the artwork, but in this case, for one particular artist, in this case, Monet. Let's see what I get back. I'll go back down below, and I'll run Python of api.py. And now we'll see what I believe are some works by Monet, water lilies being one of the more famous ones by Monet. So very cool. Now we can actually search the collections of the Art Institute using their API and using this particular artworks/search route. So why don't we give more control to the user here? If I wanted to, I could go back up here and I could say this. I could say search the Art Institute of Chicago. And I could then ask for their input for some search query. I could say type in an artist, and I'll say the input is just artist here. And now I could use this variable actually as the value for this parameter, just like this. And now a user is actually able to type in some search. We, on our end, in our program, will send that request to the Art Institute and get back all of the search results displaying the artwork titles for their particular artist. I'll go ahead and run Python of api.py down below. I'll type in Monet. Let's see what we get. Again, the same works for Monet. If I go back and run again, I'll do Python of api.py. Why don't we do someone like Picasso? I'll hit enter here, and we'll see some works from Picasso. So here we've made a way to search the Art Institute within our own program. And this really shows us the power of APIs, a way for us to actually use these routes over the internet, parameterized with various parameters, to access data that didn't exist in our program, but instead exists somewhere else. They're a way for us to interface with other computers, other systems, other networks, in this case, a way for us to get the data we wanted. This is it for our shortened API calls. We'll see you next time. Well, hello one and all, and welcome to our short on creating modules and packages in Python. In this case, I have a program called search.py to search the collections of the Art Institute based in Chicago. Now, I have a function here called getArtworks that introduces some abstraction to my program. This function takes two parameters, query and limit, and what I've done in here is made an API call to the Art Institute to search their collections using using this query and getting back some number of artworks up to the limit. Now, this is an example, again, of abstraction, a way for me to write some code, be sure that it works, and then use it to build something better. In this case, I'm taking that functionality I abstracted away in GetArtworks and using it to prompt the user to enter in some artwork they want to search for, and then seeing the results in their console. User function works, and again, of abstraction. A way for me to what I've done in here is this function takes two parameters, query and limit, and what I've done in here is made an API call to the Art Institute to search their collections using this query and getting back some number of artworks up to the limit. Now, this is an example, again, of abstraction, a way for me to write some code, be sure that it works, and then use it to build something better. In this case, I'm taking that functionality I abstracted away in GetArtworks and using it to prompt the user to enter in some artwork they want to search for, and then seeing the results in their console down below. So let's try it. I'll run python of search.py, and I'll type in water lilies, just like this, and I'll get back 3 of the artworks at the Art Institute in Chicago that have to do with water lilies. Now, this is an example of good programming. I'm extracting things away. This is like try to search and build for me to the write some code, taking that word as an example, again, of abstraction. Away to abstraction to my program. This function takes two parameters, query and limit, and what I've done in here is made an API call to the Art Institute to search their collections using this query and getting back some number of artworks up to the limit. Now, this is an example, again, of abstraction, a way for me to write some code, be sure that it works, and then use it to build something better. In this case, I'm taking that functionality I abstracted away in Get Artworks and using it to prompt the user to enter in some artwork they want to search for, and then seeing the results in their console down below. So let's try it. I'll run Python of search.py, and I'll type in water lilies just like this, and I'll get back 3 of the artworks at the Art Institute in Chicago that have to do with water lilies. Now, this is an example of good programming. I'm extracting things away, but I'd argue there's some functionality we could be missing out on. If I wanted to use get artworks, let's say, this function I defined in this file, elsewhere, how could I do that? Right now, I can only use it in search.py, but maybe I want to use it in other programs too. Well, in that case, I need to put getArtworks as a function inside its own module. Now, a module in Python is simply some Python file that I can import, much like I imported here requests. If I go ahead and make a new file here, maybe one called, let's call this one artwork.py, I can, as long as I go ahead and put this function in that file, import it, much like I did requests. I'll cut and paste this, and I'll put it now in artwork.py. I'll, again, import requests, just like this, because go ahead and put this function in that file, import it, much like I did requests. I'll cut and paste this, and I'll put it now in artwork.py. I'll, again, import requests, just like this, because requests is needed for getArtworks to function properly. In search.py now, instead of importing requests, what I could do is actually import the getArtworks function from my now artwork module. How could I do that? Well, the same way I import other modules. I could say from artwork, the module name, import getArtworks, the function name. And in this case, I could run search.py, go down below, and search for water lilies. And now I see those same 3 artworks, same functionality, but in this case, I'm introducing a module for me to reuse getArtworks across multiple programs, not just search.py. Pretty good. So what else could we do with this? Well, let's say I wanted to also have maybe a way to search for artists. I could make for myself a new module, one called artists.py, let's say, and I could take some similar functionality from getArtworks. I'll simply cut and paste this over to artists, and I'll change this to getArtists. We're going to be searching artists now. I'll change the route that I'm requesting in the API to the appropriate one, and I'll go down below, and I'll make sure that our variable names reflect that we are working with artists. All right. I think that should be it for our getArtists function. Now in search.py, I could similarly say from, in this case, from artists, import, in this case, getArtists as well. Why don't we update our program too? I could say artist, and we're going to store that in a variable called artist. I could then use getArtists, much like I used getArtworks. My query will now, of course, be the name of the artist the user wants to search for. And I'll get back a list, in this case, of artist names. I'll then iterate over every artist in the list, and I'll then print out the name of that artist down below. Let's try this program. I'll run Python of search.py, and I'll type in an artist's name, let's say Monet, and now I'll see all the artists that have names similar to Monet. So here I have two different modules, and I've imported them using the from module name import function name syntax. I don't have to do that though. I could also use the other syntax. I could say something like just import artwork and import artists, and I could then make it clear in my code which function I'm referring to in each module. For instance, in the artists module, I want to use the getArtists function. So import artists, let's try this. Python of search.py. Oh, I think this might not work because, gotta be careful here with your module names. Notice how this is not highlighted and this is not highlighted either to indicate a module name. It might be because in this case we're using the artist variable name. Let's try it though. Python search.py, Monet. Yeah, so it seems like we're shadowing, in this case, the name of the module by using this variable. So let's not do that. You could, of course, use this syntax more generally with your modules, but in this case, because of our variable names, we're going to avoid the trouble here. So what else could we do with this? If we go back to what we had before in terms of importing from the module name, import a function name, you might notice some repetition. If I wanted to use all these modules in my program, it might get a little tedious to keep saying from the module name, import this function, from the module name, import this function. So a few solutions. One is, in each of these modules, I could of course define more than one function. I could define more than getArtists inside of artists.py. I could define more than getArtworks inside of artwork.py. But I could also create a package in Python. Now, a package is a collection of multiple modules, and I can create one by making a folder and putting inside of it some special file. I'll show you what that looks like. If I go over here and make a new folder, I might make an entire package called Museum. And you can imagine this package including lots of modules that help me interface with the museum, much like artists and artwork do. Now, if I want artists and artwork to be part of, in this case, my package, I need to do a few different things. One is I need to move them inside of this folder. So I'll move artists.py into the museum folder, my museum package. I'll also move artwork.py into the same folder. And now, to note that this is a package, I'll go ahead and add this special file, dunder-init.py. This file does not need to have anything inside of it. This just helps Python realize that yes, this folder is a package including multiple modules. So now that I have a package called Museum, how can I use it in my code? Well, again, very similar to how I use other packages. I could say from, in this case, my package name is Museum. Well, here I have multiple modules to choose from. Artists and artwork, I could say from museum.artists, let's say, import getArtists. And now I'm able to access that same getArtists function. I'll run Python with search.py, I'll type in Monet, and see the same results. The benefit now being that I'm able to consolidate a lot of these modules under one umbrella, in this case, museum, and of course that umbrella being my own package name. Packages are a great way to share code, to help others use your code. So I'm excited to see what you make with your own modules and packages. We'll see you next time.